In 1965, Alexei Leonov's spacesuit inflated so badly during the first spacewalk that he couldn't fit back through the airlock. He had to bleed oxygen from his suit while floating in the vacuum of space, gambling his life on a design flaw no one predicted. He barely survived. And the terrifying truth is, a spacesuit isn't protection. It's a negotiation with 15 different ways to die. What you're about to discover will change how you see every spacewalk footage you've ever watched. We're going inside the most complex garment ever engineered, a machine that must simultaneously be a pressure vessel, a climate control system, a radiation shield, and a life support station, all while allowing a human to do useful work with their hands. From the surprising reason spacesuits are white to the engineering nightmare of keeping fingers flexible at 4 psi, this is the complete story of how a 200-pound wearable spacecraft keeps fragile human biology alive in the most hostile environment we've ever entered. Space doesn't care about you. At 300 kilometers above Earth, there's no air pressure. Zero. Your blood doesn't boil instantly. That's a myth. But without a suit, you'd lose consciousness in about 15 seconds as oxygen rushes out of your lungs and dissolved gases in your tissues start forming bubbles. Your skin would swell, your eyes would dry out, and within 90 seconds, you'd be dead. The spacesuit's first job is pressure, not Earth pressure. That would be impossible. Your suit operates at roughly 4.3 psi, about a third of sea-level atmosphere, using pure oxygen to compensate for the lower pressure. This creates a problem engineers call the balloon effect. Inflate a rubber glove and try to bend your fingers. That's what astronauts fight against with every single movement. Here's something that should disturb you. At 4.3 psi, an astronaut's suit contains about the same internal pressure as a car tire. One micrometeorite puncture, and that pressure wants to escape violently. The pressure bladder, the innermost layer, is made from urethane-coated nylon, incredibly thin, incredibly precise. It must hold pressure for 8 hours minimum while an astronaut moves, bends, twists, and works. Every seam is a potential failure point. Every fold is stress concentration. Engineers solve this not with stronger materials, but with geometry. Constant volume joints using cable restraints and clever folding patterns allow movement without the suit trying to straighten out like an inflating balloon animal. The temperature in space isn't one thing. Step into direct sunlight and surfaces can reach 250 degrees Fahrenheit. Rotate into shadow, and that same surface plunges to minus 250. This isn't weather. It's thermal assault from two directions simultaneously. The outer layer of a spacesuit, the white fabric everyone recognizes, is actually 14 layers of material working together. Orthofabric, a blend of Teflon, Kevlar, and Nomex, provides abrasion resistance and thermal protection. Below that, alternating layers of aluminized mylar and Dacron scrim create what's essentially a wearable thermos, reflecting radiation while minimizing conductive heat transfer. Your body produces about 100 watts of heat just sitting still. During a spacewalk, astronauts generate up to 300 watts. Where does that heat go when there's no air to carry it away? This is where the liquid cooling and ventilation garment comes in. What astronauts wear directly against their skin. 300 feet of thin plastic tubing carries temperature-controlled water across the body, absorbing heat and cycling it to the primary life support system backpack. That backpack contains a sublimator, a device that releases water into vacuum, where it instantly freezes and sublimates, carrying heat away with it. It's elegant engineering. It's also consumable. Spacewalks have hard time limits partly because the water runs out. Oxygen is only part of the equation. What you exhale is the real problem. Every breath releases carbon dioxide, water vapor, and heat. In a sealed suit, CO2 accumulates fast. At concentrations above 3%, you experience headaches and confusion. At 8%, you lose consciousness. At 20%, you die. The life support backpack contains lithium hydroxide canisters that chemically scrub carbon dioxide from the recirculating air. It's not a filter. It's a one-way chemical reaction that converts CO2 into lithium carbonate and water. These canisters are sized for specific mission durations. Run over time, and you start breathing your own poison. Apollo 13 astronauts nearly died not from the explosion, but because the lunar module's CO2 scrubbers weren't compatible with the command module's canisters. They jury-rigged a solution using plastic bags, cardboard, and tape while carbon dioxide levels crept toward lethal concentrations. Humidity control matters too. Water vapor from breathing and sweating must be removed, or it condenses on the inside of your helmet. Imagine trying to perform precision work in space with fogged-up vision. The ventilation system circulates air past your face and through the life support unit, where moisture is extracted and the air is returned dry and oxygen enriched. But there's one threat spacesuits handle that almost nobody talks about, and it's the reason astronauts perform specific rituals before every spacewalk that can add 4 hours to their day. Decompression sickness. The bends. It's the same thing that kills scuba divers who surface too fast, and it's why astronaut preparation for spacewalks is so elaborate. At lower pressures, nitrogen dissolved in your blood can form bubbles in your joints, muscles, and nervous system. The results range from excruciating pain to paralysis to death. Before every spacewalk, astronauts breathe pure oxygen for hours inside the airlock, gradually purging nitrogen from their tissues. The ISS airlock is depressurized in stages. Some protocols involve sleeping overnight at reduced pressure. This isn't caution, it's survival. Skip these steps, and the spacewalk becomes a medical emergency waiting to happen. Radiation is the other invisible killer. Beyond Earth's magnetic field, astronauts face solar particle events and galactic cosmic rays, high-energy particles that damage DNA and increase cancer risk with every exposure. Current spacesuits provide minimal radiation protection. The mass required for meaningful shielding would make suits unwearable. This is an unsolved problem. Every spacewalk is a calculated radiation dose added to an astronaut's lifetime allowance. A single major solar event during a lunar spacewalk could deliver a lethal radiation dose in hours. Current suits have no defense. Astronauts would have to reach shelter or die. Mobility is the final frontier of spacesuit engineering. Every improvement in protection typically reduces flexibility. Every increase in pressure makes movement harder. Modern suit gloves are engineering masterpieces with bearings in the finger joints and carefully designed restraint systems. Yet astronauts still finish spacewalks with damaged fingernails and hand fatigue from fighting suit pressure for 8 hours straight. What strikes me about spacesuit engineering isn't the complexity, it's the honesty. Every design choice represents a trade-off between competing deaths. More pressure means better oxygen, but less mobility. More insulation means thermal protection, but increased weight. Better radiation shielding means suits too heavy to move. These aren't compromises made from laziness. They're negotiations with physics itself. The next generation of spacesuits, being developed for Artemis lunar missions and eventually Mars, face challenges we haven't solved yet. Lunar dust that cuts through fabric at the microscopic level. Mars dust that may be toxic. Radiation exposure accumulated over months instead of hours. The engineering problems of keeping humans alive in space aren't behind us. The hardest ones are still ahead. Here's my question for you. Given the risks, do you think we should keep sending humans into space or focus on robotic exploration until we solve these problems? I'm genuinely curious what you think. Drop your answer in the comments. If this kind of engineering deep dive is what you're here for, subscribing tells the algorithm this matters. It helps more than you know. Spacesuits aren't clothing. They're the most personal spacecraft ever built. And every time an astronaut steps into vacuum, they're trusting their life to engineering that started with a Soviet cosmonaut who couldn't fit back through a door.